Hi guys, thanks for watching today. Wish you were in class for reals, but glad you're watching if you weren't in class. We're just finishing up the 1.5 notes today. We did the first half of them before Thanksgiving break, and now we'll finish up. So really today it's just number 4 and 5 on the guided notes. Number 4, talk about rational, which means fraction exponents, and how they are really just radicals in disguise. Do some examples of switching back and forth between exponential and radical form. I don't think you've ever seen fraction exponents before. I think this will be the first time. So all they really are, though, is radicals or roots in disguise. Here's the rule if you want to pause the video and copy that down. X to the a over b power really just means the b root of x to the a power. Main job here is to remember the top number, the numerator in the fraction, is the power. The bottom number, or the denominator of the fraction, is the root. As long as you can keep those two things straight, you're in pretty good shape. So a couple examples here. Write each expression in radical form. That's what we'll do for these first few examples. First one is a to the 5/6 power. So remember, that's just a root. And then you just have to remember where the 5 goes and where the 6 goes. So remember, the root is the denominator. The power would be the 5, the top number. So you just switched it from a fraction exponent into radical form. The next one, 5 times x to the 1/3 power. Now, because there's no parentheses anywhere, the 1/3 power is only really connected to the x here. The 5's just hanging out front, multiplying everything. So it'll be 5 times, and then we'll switch this next part to radical form. The 3, the bottom number, is the root. The 1 is the power, which I guess you don't even have to really write that one there. And then on part C, 54y in parentheses, all to the 2/3 power. That 2/3 you got to remember from our last lesson, you got to distribute that in there to both of them. So it'll be 54 to the 2/3 power times y to the 2/3 power. And then you can change each one of those to radical form. Oops. Hopefully you can start to remember which one goes where. It'll be the 3rd root and the 2nd power. So that is changing them from exponential form to radical form. On example 2 here, we're going to go the opposite way. They start in radical form, and we've got to switch them over to exponential form. So this first one, the 3rd root of s squared. So remember, we'll change that to a fraction power. The power, which is the 2, goes on top. The root, which is the 3, goes on the bottom. So it'll be s to the 2/3 power. Part B, that 12 is just hanging out in front. It's not affected by the 3rd root or anything because it's not inside of it. X, the fraction power, the 4 will go on top, and the 3 will go on bottom. Part D, which should really be part C, the 4th root of 256a to the 8th power. Just think about this separately in 2 different parts. The 256 is to the 1st power. So if we do the 256 part, the fraction exponent or the rational exponent would be 1/4 times, and now we do the a part separately. Let's see, it'll be 8/4, which 8/4 really just simplifies to be a 2. So we'll have 256 to the 1/4 power times a squared. That's about as far as we can simplify it. So hopefully you feel confident going both ways, from radical form to exponential form and vice versa. Now there are some where we have numbers, we don't have variables like x's or y's in there. So we can evaluate these. We can just simplify them down as far as possible and get a number answer. First one is 16 to the 3/4. So if we use our rule from above that we wrote down, that turns into radical form. The 4 would be the root and the 3 would be the exponent. Now it does not matter which order you go in. You can do the 4th root first, or you can do the 3rd power first. Now 16 to the 3rd power is a pretty big number. I don't even know what it is, but I know it's pretty big. So I actually always prefer to do the roots first, just to keep my numbers smaller. So we can do the 4th root of 16. In other words, what number to the 4th power equals 16? Well, that's 2. And then the 3rd power is still just hanging out there. 2 to the 3rd power is 8. So 8 would be your final answer on that one. 27 to the 4/3 power. Let's change it to radical form. The 3 would be the root, the 4 would be the power. Once again, I don't know what 27 to the 4th power is. It's a large number, so I prefer to do the root first. So the 3rd root of 27, I know that's 3. Still have that 4th power hanging out there, so 3 to the 4th power is 81. Which you can check me on your calculator on those. So when you're supposed to evaluate, yeah, just change it to radical form first, and then do the root and the exponent. You will get your answer. Number 5, last but not least, let's do some examples where we use exponent rules, but the exponents are sometimes fractions. Same exponent rules that we learned about, I believe it was section 1.4, but now a few of the exponents are just going to be fractions. Here we go. Example 1, when I have a bunch of stuff in parentheses and I have this exponent, which is 1/2, sitting to the outside, you got to distribute that thing. That was one of our rules from our notes the other day. And when you do a power to a power, that's another one of our rules, you got to multiply the powers together. So 2 times 1/2 is just 1, so that'll just be a. -3 times 1/2. Remember, this is like -3 over 1, and then you times the tops and you times the bottom. So it'll just be -3 over 2. A to the 4th to the 1/2 power, that would just be a squared. B to the 5th to the 1/2 power, that would be b to the 5/2 power. Same rules, you're just going to have some fractions involved. Let's see, the only thing I have to move around is I have to kick that b to the -3/2 power down to the bottom. So that b to the 5/2 stays there, and the b to the 3/2 gets kicked down to the bottom. Now I can simplify, I can kind of combine my like terms. So if I look at the a's, it's like an invisible 1 right here. The rule when you're dividing is you actually subtract the exponents. 1 minus 2 is -1, which would kick that a down to the bottom. I have these b's now. When you multiply, you actually add the exponents. These are nice because they've already got a common denominator. 5/2 plus 3/2 is 8/2. 8/2 just simplifies to be 4. So it'd be b to the fourth down on the bottom. Nothing left on top, so we just kind of put a 1 there as our placeholder. So there's your final answer for that example. Let's try one more. I've got to distribute this 1/3 power. So I will have x to the 5/3 times y. 6 times 1/3 would be 6/3, which is just 2. Z to the 0 to the 1/3 power. 0 times 1/3 is still just 0. Times x, y to the negative third. So I distributed that 1/3. Now, anything to the 0 power is just a 1. So I can basically just get rid of that z to the 0 power. It's just a 1 hanging out there. Next, we can kind of move things around. The x to the 5/3 would stay up top. The y squared would stay up top. This other x from over here would stay up top. The only thing that gets moved is this y to the negative third right here. Whoops. That'll get kicked down to the bottom. Kind of combining my like terms, if I look at the x's, I've got a 5/3 and a 1. I need to add those together. When you're adding fractions, remember you need a common denominator. 1 is really like 3/3. So 5/3 plus 3/3 would be 8/3. And then with the y's, 2 minus 3 is negative 1, which means I will have a y down on the bottom. So like I said, same rules that we've been working with. You'll just have some fraction or some rational exponents. That is it for the notes. You guys are awesome. The worksheet today, I will just post on the Canvas page so you can print that out. Thanks for watching. You're awesome. Have a fantastic day.